Yes, good evening, and thank you very much for invitation. This is my first opportunity to speak at this meeting, and I'm going to talk a little bit about the history and astronomy in combination, and specifically about Johannes Kepler. He was born in Wilderstadt in Germany. This is the current picture, the city hall in the birthplace of Johannes Kepler. Prior to his birth, there was the universe was centered on Earth, and that sort of started with Claudius Ptolemy. And here you can see this Earth in the middle, orbited by Moon, Venus. I guess the Mars wasn't discovered by that time. Then by Sun, Mars, and then all the stars. It's called geocentric view of the planetary system. That was endorsed by Church, and any planetary system would be a bit of a heresy. Then in 1543, Copernicus published his book on the revolution of celestial spheres. This proved to be a major event in the history of science. He wasn't quite sure whether this is true or not, but his view was supported by Johannes Kepler and Galileo Galilei, among others. However, Martin Luther did not think too much of it, and he said Copernicus was a fool. Now, enter the Danish astronomer Tycho Brahe. He was born in 1546 in Denmark. He had the best observation data for planetary motions. There was these observations were with great accuracy. Here's his picture with his neural quadrant, and of course, here is the man, a man with a golden nose. It wasn't really a golden nose. He lost his nose in a duel. And it was really just brass nose on his face. When Tycho lost support from the new Danish king, he moved to Prague in 1599. In Prague, that was the capital city of the Holy Roman Empire, he worked for the Emperor Rudolf II. Here in the middle. The Rudolf II was the patron of arts and sciences. And in 1600, Tycho invited Johannes Kepler to make sense out of his planetary measurements. Now, both men argue often. Brahe was aristocratic. He treated Kepler as his assistant and not as his equal. Brahe also kept his observational data close to his chest. Finally, he gave Kepler data on Mars. That was a difficult planet to figure out. Today we know the reason. Mars has a definite elliptical orbit. Kepler replied, he will have it sorted out in a month. It took him 8 years. In a process, he had to invent derivatives and calculus, some 60 years before Newton and Leibniz. This is the contemporary picture of Prague, Old Town Square. At the background is the Church of Our Lady. That's where the Tycho Brahe is buried. He died after short illness in 1601. At that point, the Johannes Kepler was appointed to his position at much reduced stipend, I must say. There is a Kepler Museum of Astronomy in Prague. It's in one of the houses where Johann Kepler resided. He spent a good time of his life in the Bohemian capital at the beginning of 17th century. And it was here he carried out most of his important works. Kepler discoveries can be summed up in the 3 laws of planetary orbits that stood the test of time. I'm reading that just to make sure that I catch up on my allotted time. The first 2 laws were published in Astronomia Nova in 1609. And here comes the first interesting part, that Kepler begins to describe the planetary orbits as elliptical orbits, not a perfect circles as it was believed at that time. The second law states that the orbital speed changes with a distance to the sun. A planet covers equal area between the planet and the sun in equal time. Kepler called the unknown force that kept the planets in the orbit around the sun mysterium. Today we call it gravity. All he wrote was always in Latin. That was the language of communication at that time. So here's the first law of planetary orbit, and of course its ellipse. That was a great revelation, because the circle up to that time was considered a godly perfection. However, there are no perfect circles in the nature. Neither there are perfect elliptics, as we would later discover. The second law is that the planet orbit sweeps the equal area in equal time. Closer to the sun, the planet moves faster. The farther from the sun, the speed of the planet slows down, but this area is equal, not on this picture, but in reality. Derivative calculations are required to measure these areas. In 1619, finally, Kepler published his third law of planetary motions in his book, The Harmonies of the World. The book was published in the 30-Year War that started in 1618. It was a religious war between Protestants and Catholics. Now, the third law is most interesting. And I like the equation here that I put, and it essentially says the square of orbital period is proportional to the cube of semi-major axis. Now, this is the major axis of the orbit, and semi-major axis would be the radius. These are the minor axes. Now, again, there is a relation, that's a very specific relation. When you divide the square of the period by the cube of semi-major axis, it equals to a constant. That was a principal thing in his discovery. Furthermore, this Kepler's third law, and this is a modern notation, can be easily transferred into this equation and then further on to the famous Newton's law of gravity, where force of gravity equals gravitational constant, mass of sun, mass of planet, divided by r square. However, Kepler faced the uphill battle back in the 17th century, and that's shown in this cartoon. He says, so you see, the orbit of a planet is elliptical. And of course, the learned men were asking the question, what's an orbit? What's a planet? What's it elliptical? Kepler noted in one of his letters, It may take 100 years before somebody will read my book. It took about 50 before Isaac Newton read it. Kepler complemented the beauty of his third law, and scientists have been complementing it ever since. Today, the Kepler laws are utilized in studying everything from binary star systems to the orbit of galaxies. Now, here again, we are back to the Earth-centric system, but these are the scientists that managed to break through it. This is the picture of Copernicus, picture of Tycho Brahe, Galileo Galilei, Johannes Kepler, and finally Newton. And of course, by 18th century, the heliocentric system was accepted. Isaac Newton didn't give too much credit to Kepler for his discoveries in astronomy, optics, and calculus. And by reading different books on that subject, I now see the reason. Newton practiced alchemy for 20 years with no results. English alchemists who worked at Prague at the court of Rudolf II were criticized by Kepler. And I think the Newton kind of remember that. Here are the alchemists in Prague's Tower Museum. Perhaps you can recognize some. I'm the one in the middle, by the way, just in case you missed the joke. Life for Kepler and his family was not easy. During the 30-year war, he lost his friends, some of his children died, and even his wife grew despondent and died soon after of typhoid. On top of that, his mother was threatened with torture and was barely acquitted of witchcraft, due, the court records noted, to the unfortunate intervention of her son, the imperial mathematician, as attorney for the defense. And after her release, she died 6 months later, after her release from the prison. I would recommend this book very highly. It's called Kepler's Witch. It's about Kepler and his discoveries and his life. And one chapter is also devoted to his mother, respectively to the Kepler's defense of his mother. She was prosecuted by the magistrate Luther Einhorn, who prosecuted 15 witches. And about 8 of them were burned. Those were the different times. In 1627, Johannes Kepler published the Rudolphine Tables. The tables are named as Rudolphine in memory of the Rudolf II, Holy Roman Emperor. The purpose of Rudolphine Tables was to predict the positions of the planets based on his calculations. There is also a Kepler's Museum in Wilderstadt. As I noted, that was his birthplace. During the 30-year war, Kepler followed and worked for Imperial General Albrecht von Wallenstein, making astrological predictions, but was rarely paid on time. He wasn't into the astrological predictions, but he had to make the living. And the general needed those predictions to know when and where to go into battle. Finally, Kepler, alone on horseback, drove to Regensburg hoping to collect fraction of his payments. There he fell ill with a fever and died on November 15, 1630, at the age of 58. Before his death, Kepler wrote, and is the English translation, "I measure the skies, now I measure the shadows. Skybound was my mind, the body rests in the earth." This was the epitaph on his grave outside of Regensburg. The grave vanished under the war. However, Kepler's legacy is being finally recognized. In 2009, NASA launched Kepler telescope into the Earth's trailing heliocentric orbit to discover exoplanet. Why exoplanet? Well, it was the Kepler who told us about the way the planet orbit the sun. And this is the picture of the Kepler telescope. Now, in this image, you see the exoplanet. Those are the planets outside of the solar system. The yellow ones, the yellow marks, are the ones that were discovered by the Kepler telescope, whereas the blue one are that were discovered by other means. As you can see, the blue ones line up on top of the chart, and they are about the size of Jupiter or Saturn. It's the yellow exoplanet that sort of reach down to the size of the Earth, or even lower. Now, the way the planets are discovered is that the special telescope looks at the individual star and watch for the dimming. That means that there would be a planet transiting across the disk of a star. That can measure several things: the size of the planet, depending on the amount of dimming. It measures the orbit of the planet, depending how fast it moves across. And by measuring the speed, we can also measure the distance of the exoplanet from the star. It's all in combination, and it's all reflected in Kepler's laws of planetary orbits. Now, in 2018, there was a problem with one of the solar panels, and they had to adjust the Kepler telescope by using the fuel cells. And eventually the telescope ran out of fuel. Telescope cost $550 million US. That's quite an amount. And I guess after the telescope is no longer sending us images, that means that the NASA will have to write it out or write it off. I do not know how would I write off $550 million. It's an astronomical amount, but I understand the NASA is in the astronomical business. Here are some of the key days of Johannes Kepler, that if I have any questions from the audience, I will be able to look up the dates. Again, thank you very much for your invitation.
And I just wanted to share a comment that some of our members know this. If they're not aware of it, we have a library, pretty substantial library with a wide variety of science and astronomy books. It's located at our member observatory on the Blue Mountains, so not quite accessible at this time. but the person that manages the books at the library, he let me know that we do have a copy of Kepler's Witch. So I think that book might be signed out in the future.
Yeah, I found that book very informative. That's not the only book that sort of describes the Kepler. There are other publications on the subject. But I found this one rather interesting, both from the historical point of view, as well as about Kepler's discovery and his times.
Okay, thanks, Jerry.
Thank you.